Hello everyone. In this video we are going to discuss practice exercise 2.3 from second chapter of Elements of Electromagnetics. So if you are new to my channel, so please do subscribe my channel, and if you have any feedback for me, so please do write it in the comment box. Okay, so we will start with what is given to us and what is to be done within this numerical. So very firstly we are given with some vector h, which is basically expressed in terms of cylindrical coordinate system, since we have that rho phi and z over here, and we have to find out what is the dot product in between that vector h and ax at some point, and that point is given to be 1 pi by 3 and 0. Then we have to find out what is the cross product in between that vector h and a theta. Then next is we are going to find out the scalar as well as the vector component of that vector h. Okay, so we will start with the very first part of the numerical, that is we are going to find out what is the dot product in between that given vector h as well as that ax. Okay, so very firstly we will start by writing that given vector h, and we are going to find out what is that vector h at this point, which is 1 pi by 3 and 0, and then we are going to have the dot product with respect to that vector ax. Okay, so this is what we are given with vector h, and we have to find out what is that vector h at point 1 pi by 3 and 0. So at point 1 pi by 3 and 0. So if you look out for your given points, you can see that it is given in terms of that rho, phi and z. So very firstly we are going to find out what is that vector h at that given point, which is 1 pi by 3 and 0. So what we are going to do, we are going to simply put the values of that rho, phi and z within the given vector equation. So we have the 1 value for your rho, then we have that z is equals to 0, then we are going to put that value of phi within this cos, so which is cos of pi by 3, then this a rho cap, it will be as it is, then e raised to the power minus 2, it will be as it is for now, then we have that sine of pi by 2. So here in this case that will be sine of pi by 3 divided by 2, and this will be your whole bracket. So this sine of pi by 2, it is related with what? Sine of pi by 3 divided by 2. So this is how we are going to express that sine of pi by 2. So it is associated with that a phi component. Then rho square. So rho square is again what value we have for that rho, which is 1. So that will be 1 square az cap. Okay. So this is what we have. Now we are going to simplify this equation after putting that values. Okay. So if you look out for the very first term, so it is to be multiplied with 0, and anything multiplied by 0 is what? We have that value to be the 0. So that will be component along a row. Then another, your second term. So second term is what now? We have that to be the e raised to the power minus of 2, then sine of that pi by 3. Sorry, already we have written that one, so we are not going to rewrite that one. So e raised to the power minus of 2, which is to be multiplied with that value. Okay, so we are going to find out what is that sine of pi by 3 by 2. So if you are going to have the calculations, so we will find that sine of pi by 3 is that will be 60, and 60 divided by 2, so that will be 30. So this term will be what now? It will be your sine of 30 itself. Okay, so if you are going to have the calculation in degrees, and what about radians? So you can put that your calculators within that mode, and you can simplify it for that radius. Answer will be same. That will be what now? That will be 0.5. So we have that to be the a phi cap, and this 1 square is 1. So that's why we have the last component to be az cap. Again we are going to simplify this one. See, this is I am going in a step-by-step manner, so that I am assuming that my viewers are newcomers or new to this field of electromagnetics. So it might be boring for the intermediate viewers. Okay, so you can go with the 2 times of the speeds for that one. Okay, so meantime we have solved that and we have found that this will be first term will be as it is, so that will be 0 aero cap, and then this after simplifying that one, so we have this answer to be 0.06767. So this will be what now? 0.06766 A5 cap, and this will be as it is. So that is what is your AZ cap. So this is what? This is your given vector H, which is expressed at point, or you can say the given point, which is 1 pi by 3 and 0. Okay, so this is the given vector H at that point. Still we are left with that A part of this numerical. Now we are going to move on to the A part of the numerical. So what is that A part of the numerical? We have to find out the dot product in between given vector H and AX. Okay, so we are going to simplify that one. So A part is what? We have to find out the dot product in between that given vector H and AX. So we earlier we have found out this vector H, say for equation 1 to this vector H, which is what? So 0 aero cap, so I am not going to rewrite that one since it is with the 0 component. What is left over here? We have that value to be, sorry, we have that value to be what? 0.06766 A5 plus AZ cap, and then we have to take its dot product with respect to AX. Now you can refer to the dot product table. Hope you have referred my previous videos so that you will have the answer for that one. For now I am going to write the answer directly over here. Okay, so the dot product in between that A5 and AX. So the dot product in between that A5 and AX will be what now? So the dot product in between that A5 and AX is what? Minus of sine phi. So I am going to write that over here again. So minus sign is for that minus of sine phi again, sorry. So that will be what now? 0.06766 sine of phi, and we have that phi value to be what? Pi by 3, and the dot product in between this AZ and AX is what? 0. You can refer that my previous lectures for this. Okay, so if you are going to take the dot product in between these two values, or if you are going to put the value of that sine of pi by 3 and multiplied, get it multiplied by this minus 0.06766, so you will have that answer to be minus of 0.0585. So this is your answer for that dot product in between the given vector H along with that AX value. Okay, so this is the answer for your A part of the numerical. And here I am going to write that note. If you are still newcomer or very firstly watching this video, so you just have to refer that transformation table. Sorry, my handwriting is not as good as yours, so we just have to refer for that transformation table. Okay, you can refer my previous videos. Okay, fine. Now we are going to move on to the B part of the numerical. Now within the B part of the numerical, we have to take the cross product in between the given vector H along with the A of theta, or unit vector along theta direction. Now if you look out, your ours is given vector H, which is expressed in terms of cylindrical form, and we have to take its cross product with respect to the spherical form. So it is not likely to happen. So for that purpose, very firstly we are going to convert that given vector which is a theta into its cylindrical form, and then we are going to have the cross product. But before that, very firstly we are going to convert that given point which is earlier expressed in terms of what, that rho, phi and z. That means what, it was expressed in terms of cylindrical form, so we are going to convert that cylindrical points into the spherical points. Okay, so I'm going to write it for you. Okay, so we are going to convert that point into its spherical form. So for that purpose, we have what we have. You can refer to my previous slides or previous lectures. Okay, so we have that r to be square root of x square plus y square plus z square, but we don't have x square plus y square. So what we have? We have that rho. So that will be what now? Rho square plus z square. Okay, so what value we have for that rho? We have that rho to be 1 square, and z is what we have? 0 square. So from this we have that r is equals to what now? R is equals to 1. Okay, this rho square, it comes from the fact that we have that rho is equals to square root of x square plus y square. And if you are going to square that one, so we have that rho square is equals to what? X square plus y square. So this is how I have written that rho is equals to square root of that x square plus y square. Okay, so this is for your just reference purpose. There is no need to write it down in your theoretical exam. Okay, next is what? We have that theta. So theta is what? Theta is cos inverse of z upon r. We have z, r that we have found just now. So that will be what now? Cos inverse of z value we have to be the 0, this over here. So we have that z which is 0 divided by r which is 1. Okay, so from that we have that theta is what? 90 degrees, or you can say pi by 2 in terms of radius. So we have that theta is equals to pi by 2. You can make use of your own calculations. Okay, then next is phi. So we have that phi is equals to tan inverse of y by x. But for cylindrical and spherical system, always keep in mind whatever is phi, phi is always constant. For both systems, phi is constant. Okay, so that's why we have that phi is equals to pi by 3, which is as it is. Okay, so this is what we have, that r, theta and phi. So you can say that whatever this point which is earlier in terms of cylindrical form, so that point is expressed like this one in spherical form, which will be what now? R, which is 1, theta, which is pi by 2, and then phi, which is what? Pi by 3. Okay, so we have this point. Now next is we are going to talk about the vector components in its cylindrical as well as spherical form. So given vectors is expressed in terms of its cylindrical form, and if you want to convert that cylindrical vector into its spherical form directly, so we have these radial components, that is radial component along that r is ar cap, which is equals to sine theta arrow plus cos theta az cap. Then next is a theta cap, which will be equals to what now? Cos of theta arrow minus sine of theta az cap, and this phi component is constant, so we have that a phi is equals to a phi. Now if you are referring my video for this numerical, and if you have any confusion regarding this cylindrical to spherical vector components or how they have been converted, you can write it in the comment box so that I will try to make a dedicated video for this conversion. For now, for this numerical, you just keep in mind that we have these values of that AR, A theta and A phi when we have the conversion from its cylindrical form to spherical form. Okay. Now, if you look out for that part B, so what is asked? We have to take the cross product in between that vector h and a theta component. So we are just going to discuss about that a theta component over here. Okay, so we are going to put the values of that theta that we have found out earlier, which is this one within this AR and a theta and a phi cap. Uh, okay, let me simplify over here itself. I was trying to skip that part, but I think you might get confused, so that I'm going to solve it for you. Okay, now we have this value for that AR, which is the radial component, and that radial component AR. If you are going to put the value of that theta over here, so what we are going to find? Sine of theta, and theta is what we have. This is our theta, which is pi by 2. So that will be sine of pi by 2 a rho plus cos of pi by 2 a phi, sorry, not a phi, that is a z. And if you are going to simplify that one, so we know that sine of pi by 2 is what? 1 and cos of pi by 2 is what? 0. So from that we can say that whatever is the radial component is same as that of the this arrow component. Okay, so we have that both values to be same for that vector components. Next is we are concerned with the value of this a theta. So we are going to solve that one. So a theta is what? Cos of theta, which is what? That will be cos of pi by 2 a rho minus sine of theta, and again we are going to put that theta to be pi by 2 az. Okay, and then if you are going to simplify that one, so we have that cos of pi by 2, that will be 0, and minus of sine pi by 2, so that will be what now? Sine of pi by 2 is 1, so this will be minus of az. So we have the value of that a theta, which is what? Minus of az. And this phi component, so it will be constant, or you can say it will be as it is here in this case. A phi is same as that of a phi. Okay, so we have that r theta and phi value over here. Now we are going to take its cross product. One more thing, what is likely to happen with this one? Okay, so if you are going to see this one, okay, let me put it over here. Okay, so we have that AR is equals to A rho. So if you are going to put this value over here, AR is equals to A rho. Now what is that value we have, that rho z and cos phi, and it will be what now? AR. So since we have that z component to be 0 over here, so that's why this term will be 0. So we are not concerned with that one. Okay. So we are going to take the cross product in between that given vector h and that a theta. So the cross product. Okay, so this is the part B. Already I have written earlier, so I'm not going to rewrite that one. Okay, fine. So that is what? Vector h cross a theta. This is what we are given with, but that value is what now? Vector h cross minus of az. Okay, so this comes from this. Okay, now we are going to write that one. So that rho phi and z, we have that rho phi and z. Then your vector h. So vector h is, we have found the value for that vector h over here. So what is that value we have for that rho? So component along rho direction is 0, component along phi direction is 0.06766, and component along z is again 1. So we are going to put that values over here. Okay, so row component is 0, component along phi direction is 0.06766, and component along that z is 1. Okay, so I'm going to write that z component over here. Then next is what are that components that we have for that this az value. So this will be 0, 0, and that will be minus of 1. Now take the cross product. You can refer my previous videos how we have taken that cross product. So this A row will be as it is. A row will be as it is. So cross product in between this 0.06766 multiplied by this minus 1. So that value will be what now? Minus of 0.06766. Okay. Then this 1 into 0 will be 0 plus a5 and multiplied by this 1 into 0 and this 0 into minus 1, so that term will be again 0 plus az and multiplied by this 0 into 0, so that will be 0, and this 0.06766 multiplied by 0, so that will be 0 again. So we are left with this component only, that the cross product in between that your given vector h and a theta will be what now? So we have that answer to be minus of 0.06766 aerocap. So this is our answer for part B of the numerical. Okay. Now we will move on to the part C of this numerical. So within the part C, we have to find out what is the vector component of vector h, which will be normal to the surface, which is rho equals to 1. So if you refer my previous video, we have already done this part, that is vector component will be what now? So vector component of vector h, it will have the dot product with respect to that a row, since we are given with this term, that is it should be a normal to surface which is rho equals to 1. So that's why we have taken that the dot product of given vector with respect to unit vector along the row direction, and again this row unit vector. Okay, so this is what we are going to find out. Simply we are going to put that values. So what values of, very firstly we are going to rewrite for that vector h, so which is rho z cos phi arrow plus e raised to the power minus 2 sin of phi by 2 a phi plus rho square az. Okay, so this is our given vector h, and it should be with the, it should have a dot product with respect to the unit vector along that row direction. So this is the very first bracket, this is what we have written, and then it should be multiplied by that arrow. Okay, now take that dot product. So we know that dot product in between the two same vectors is 1. So this dot product in between this arrow and arrow will be 1. So we are left with the value, that is rho z cos phi, and elsewhere it is 0. So that's why this dot product in between that a phi and arrow is 0. So this term will be what now? So this term will be 0, and dot product in between that az and arrow, that is again 0. Okay, so we are not going to write that zeros again over here. So what is left? We are left with that value which is equals to rho z cos phi multiplied, which is to be multiplied by with arrow. So this is what we have for that vector h having dot product with respect to unit vector along that row direction and this row. Okay, now we are going to put the value of that rho z and cos phi. So what is that rho that we have? Rho we have, which is given over here, rho is 1, then z is 0, and then cos of pi by 3, and it is along with that arrow vector. Okay, so what value we are left with? So anything multiplied by 0 is 0, so that's why we have that vector h having dot product with respect to arrow multiplied by arrow is equals to what now? So that will be 0 times arrow. So this is the answer for your part C of the numerical. Now next is we are going to move on to the part D of the numerical. So we have to find out what is the scalar component of the given vector h, which will be tangential to the plane at z equals to 0. So this can be, this is what earlier we have discussed in my previous video. So it will be what now? So it will be a cross product, okay, with respect to that az. So cross product in between your given vector h, and it should have a cross product with respect to the z direction, since we are given with this z is equals to 0 plane. Okay, so this is what we have found out in our previous slide. Where is that one? Yes, over here we have taken that cross product in between that vector h and minus of az. So here in this case we have that az to be a plus value. Okay, so we are going to rewrite that one. So again we have that arrow a5 and az over here, and we have this value to be what now? 0. Here we have that value to be 0.06766, and we have this value to be 1 over here, and then here in this case we have this 0 0, and this az. So az is what now? This is plus 1 now. So go in a similar manner and find out, take its cross product and find out that answer. So you will find that answer to be what now? 0.06766, because earlier we have discussed the cross product in between these two over here. So if you have any still confusion, you can refer to this part of the video. Okay, so we have this answer, which is what? So the cross product in between that given vector h and its z component, which is tangential to this plane, which is at z is equals to 0, it will have this much of magnitude, since we are talking about what? Scalar component. So it should not be associated with this vector component. So what is our answer? That will be 0.06766. Okay, so this is what we have discussed about the practice exercise 2.3 from your book. If you appreciate my video, my teaching, so please do write it in the comment box. Please do subscribe my channel and share it with your needy ones, or you can say the friends. Okay, thank you. Have a good day.